So we're going to use these definitions of our trig functions to be able to find the value of an angle given a point. So let's come down here and practice this for just a couple of times. So if I wanted to find out what the 6 trig functions were for theta, if I know that the point lies at 4, 3, you first want to start out by drawing that point 4, 3. So I have this point given by the value 4, 3, and I know that I have a line, or that's what I'm kind of talking about, is the line that passes through that point, and I'm being asked what are the trig functions for theta associated with this rotation right here. Okay, so if I know that I went in the x direction 4 and I went in the y direction 3, the only thing I need to calculate then would be the value r. That's what I'm going to start with. So I can find r by saying that r is equal to the square root of x squared plus y squared. Okay, so r would be equal to the square root of 4 squared plus 3 squared. If you were doing the math on this, you'd find out that that would be equal to the square root of 16 plus 9, which is 25. And further, you would find out that r is now equal to 5. Now normally when we take the square root of a value, we get both the positive and the negative values, but because we're talking about r here, right, and r is the distance from the origin and distances are always positive, then r will always be positive. Plus you might recognize that this is a special triangle that you learned in geometry. It was a 3, 4, 5 triangle, so you can do it faster that way as well. So now that we know the 3 components, we have an x, we have a y, and we have an r, I can list my 6 trig functions. So let's just come down here and do that. So just to be clear, let's go ahead and write so we can see them, that x is equal to 4, y was equal to 3, and r is equal to 5. Let's use those values, or let's use those to be able to find our 6 trig functions. The sine of theta is y over r, and therefore it's 3 over 5. So each time I'm just creating a fraction or a ratio. The cosine of theta is given by x over r, and therefore it would be 4/5. And the tangent of theta is y over x, which would be 3/4. These are the first 3 that I typically do, and then I come back and I fill in the reciprocals of them. So I'm going to look at cosecant, because that's the reciprocal of sine. The cosecant of theta would be the reciprocal of this, which is r over y, or 5/3. Secant of theta would therefore be r over x, which would be 5 over 4, and cotangent of theta would be x over y, which is 4 over 3. So we're able to find all 6 trig functions based on the information that was given. Let's practice that one more time. This time we're looking at the ordered pair -5, -12. Hopefully you remember that -5 is going to move this way on the x-axis, and -12 moves down on the y-axis. So I have a point out here. We're going to just call it -5, -12, and we're looking for the angle theta, because it's going to always start here on the x-axis and it travels in a counterclockwise motion. So I'm looking at this angle theta that's associated with this point down here. Now even though my x and my y values are both negative, again my r value, which I need to find first, will be positive because it's the distance. How far is it from the origin to this point? That's always going to be positive. So let's calculate what r is. We can find r by taking the square root of x squared plus y squared, and I know that that's going to be the square root of -5 squared, which is 25, plus -12 squared, which is 144, and that gives me 169 square root, which is 13. And this value then, r, is 13. And that's also a special triangle, a 5, 12, 13 triangle, if you wanted to remember that one. So if I have those three components, I know that x is equal to -5, y is equal to -12, r is equal to positive 13. Can you find the 6 trig functions that are associated with that using the definitions that we have above? Stop the video and fill that in on your paper, and we'll see if we get them the same. Okay, so here I have listed all 6 of the trig functions based on the point -5, -12. So for sine theta, we have -12/13. Cosine theta is -5/13. Tangent theta would be -12 over -5, which ends up being 12/5. And you can see the remaining 3 trig functions are just been the reciprocals of what we already got. Okay, so that's practice finding it when it passes through a point. Well, what if my question isn't stated in that way? And instead, what if my question looks like this? I again want to find the 6 trig functions of theta that's in the standard position, but I want to know these values when the terminal side of theta is defined by the line 3x minus 2y is equal to 0, and I'm only interested in the portion of the line where x is less than or equal to 0. So we need to kind of go back and think about, how do I graph a line like this? Let's take this line and let's rewrite it over here. We've got 3x minus 2y is equal to 0. And hopefully you remember from Algebra 1, the easiest way to write the equation of a line, or the easiest way to graph a line, is to put it in its y equals form. So we're going to solve this equation for y. So -2y is equal to -3x. Divide both sides by a -2, and I find out y is equal to 3/2 x. That tells me right there that the slope of my line is 3/2. And what's the intercept? The y-intercept. Well, the y-intercept, in other words, it's crossing the y-axis at 0. So that's where we're going to begin. So if I begin here and I talk about a line that has a positive slope, I would have, starting here at the origin, I would count up 1, 2, 3, and to the right 2, 1, 2, 3, and to the right 2. In other words, I have a line that looks something like this, maybe. I have a line that looks something like this, except I'm not interested in I'm not interested in the portion of the line. Let me rephrase that. I'm only interested in the portion of the line where my x values are less than 0. So in other words, I'm only interested in the portion of the line that's down here. In other words, my angle theta went all the way around and stopped down here again in quadrant 3. Now, I also know that the x value down here, when I'm in quadrant 3, the sign of my x values are negative. And when I'm also in quadrant 3 over here, the sign of my y values are negative. And we kind of need that information so that we can piece all of this together. So far I have a line drawn. So far I know the sign of both my x and my y values. What else do I need to know? Well, if I know that the slope of my line is 3/2, think back. How do we know what slope is? Slope would be the y's over the x's. Well, if that's the case, then it just defined for me what my y value and my x value are. So x would be equal to 2, but it's negative, so it's -2. Y would be equal to -3. And then we can use that to be able to figure out what r is. r would be the square root of negative 2 squared plus negative 3 squared. So in other words, that would be 4 plus, let's see, 2 squared is 4, 3 squared is 9, so 4 plus 9 is the square root of 13. So I have the x, the y, and my r value here, and I can go in and I can write down what my 6 trig functions are. So let's do that together. This gets a little bit trickier, so we'll keep that up there. So for my sine, I know that the sine of theta is equal to y over r. That would be negative 3 over the square root of 13. Okay, so we're going to stop here for just a second and remind you that, well, it should be the square root of 13. I want to remind you that you can't leave a radical in the denominator. So what I have to do is rationalize the denominator by multiplying top and bottom by that square root of 13, because that's the part I need to get rid of, is the square root. So I got to multiply top and bottom by the part I want to get rid of. When I do that, I end up with the top becomes negative 3 times the square root of 13. You just put those two values together since they're not like terms. But the denominator becomes the square root of 13 times the square root of 13 would really be the square root of 169, which is 13. In other words, when I multiply those two numbers together, that single value comes out of the radical, and we just end up with that. Okay, so if you have trouble rationalizing the denominator, then I would go search that or look back in the appendix of the book, or send me an email if you need some extra help with that. So let's practice that again. The cosine theta would be x over r, which would be negative 2 over the square root of 13. If I multiply top and bottom again by the square root of 13, I get negative 2 square roots of 13 over 13. Tangent of theta is going to be much easier because it's just y over x, which would be negative 3 over negative 2, which was 3/2. It is not coincidental that the tangent of theta is the slope of our line. So if I know sine, cosine, and tangent, I can pretty easily take these values here and find the reciprocal of them to find the remaining 3 trig functions. So cosecant of theta would be r over y, which would be the square root of 13. It would be negative square roots of 13 over 3 because it's the reciprocal of this. Secant of theta would be the reciprocal of my cosine, so that would be negative square roots of 13 over 2. And cotangent of theta is just going to be the reciprocal of tangent, which is 2/3. Okay, so there's some practice finding the 6 trig functions using either a line, like we did in this example, or using the point, as we did in these two.